Good morning, ladies and gentlemen. I would like to introduce you to the Commodore 64. The Commodore 64 is named such not because it has a 64-bit processor, because the processor is not 64 bits. It's actually 8-bit. It is not the Commodore 64 because it has 64 gigabytes of RAM, because it doesn't. It actually has 64K of RAM, and that's where the Commodore 64 comes from. 64 kilobytes. Anyways, this beautiful and classic unit was first brought to market back in 1982. Makes this thing, what, 34 years old now? So I guess I'm dating both this video and myself, and the age of the machine. It ran until 1994 in production, in which approximately 17 to 22 million units were sold. Depends on the source, but that's probably in the correct ballpark between all of the different variants and the Commodore 128 and the other units that are cost reduced. And I don't know, did anyone ever make a clone of the Commodore 64? I know there are some modern ones, but I don't know about back in the original day. So, we are going to take a quick look at all of the ports and connectors in a moment, and then I will lift the hood on this beauty, and we will look inside and see what makes her tick. So, on this side of the Commodore 64, we have two control ports, a power switch right there, and a power port. If we move over to the back side of the Commodore 64, we have a cartridge port, we have a channel select switch, an RF connector to hook it up to your TV back in the old days when there was an RCA jack with a video in on it. Right here we have an AV connector, typically used for monitors or connecting to your TV with an audio source as well. A serial port, a tape port, and a user port, which was basically another serial port with some extra pins and other goodies on it. So, let's take a quick peek at the back of this unit. Right here, we have a sticker labeling the model, serial number, and FCC ID. If we take a closer peek right here, we can get a little information about a previous owner, the Pasadena Commodore Computer Club. I wonder if any of those guys are still kicking around playing with their Commodore 64s. Down here we have 3 screws that are used to hold the entire unit together. I've already removed 2. I'll take out the last one and we'll lift the hood on this beauty. I have removed the bottom screws and disconnected a couple of connectors. This one right here is for the keyboard, and this one over here is for the power LED. Now it looks like we have some sort of metallized shield, probably made of cardboard, and that's to help keep some of the RF goodness inside so we don't pollute the radio waves and mess with the toaster and AM radios and stuff like that. Over here we have an RF can. That's for the RF section, and there we have another can covering the VIC chip and associated goodies. If we look over here, here's that power connector that I motioned to earlier, the power switch, 2 control ports, which are typically used for joysticks or other video gaming peripherals. As I understand it, some people have created mice and tablet pointers and pens and other artistic things for doing various, well, artwork. People have converted them to handle custom musical instruments. I know that sounds really bizarre since they're pretty simple on-off switch, basically. You have a couple of pins coming out, and you short them together, you get a signal, and poof, your joystick goes up. And that's basically really all those ports are. But we have some other goodness. Here's your cartridge port, where you stick all of your video games and fast load carts. Now, those fast load carts are pretty interesting bits of technology. We might take a look at what one of them does a little bit later. Probably another video. Over here we have a fuse, which is obviously for protection. A little rectifier diode and some magic power goodness. Right here is a 7805 linear regulator. Need this big heat sink to dissipate some of that extra wattage. Over here we have a 7812 12 volt linear regulator. Various smoothing capacitors, and looks like some ferrite beads to take the edges off. And this guy right here is a little crystal oscillator. Up in this RF can we have a couple other RF or crystal oscillators. Maybe they're actually filters or doing some other RF magic and goodness. I'm not entirely sure. But this chip right here is the VIC-2. That is the GPU of the Commodore 64 in modern parlance. It had associated with it a whopping 16 colors and 300 by 200 pixel graphics. That's amazing. Oh my goodness. Oh, wait. No, that's really bad. Oh well, we'll continue. We have all sorts of other magic going on over here. The chips over here are mostly made by MOS Technologies, and they're all custom. The ROM chips, the processor, the serial interface goodies, everything labeled with MOS is a custom dealy jobber. And we'll take a quick look at what all of those chips do in a moment. Let's see. Where should we start? Let's take a look at the upper left-hand corner with these two chips right here. Those two chips are called the CIA chips. I'm wondering if there's some sort of government conspiracy here. Probably not. They are essentially I/O handlers. They have serial ports. They have timers on them. They have other wonderful goodies. Handles the real-time clock, serial buses. They talk to the keyboard. They do all sorts of I/O stuff. Then we have these three chips here, which are the ROMs. The first one is the basic ROM. The second one here is the kernel ROM. And this one here is the character ROM. Now, from what I understand, and anybody correct me if I'm wrong in the comments, and I'll, go ahead and make adjustments and corrections, but the character ROM, basically all it does is store information about characters, the actual bitmaps of what the A looks like. The kernel ROM is basically the operating system. And somebody gave it a weird backronym where kernel stands for something, and I don't know what it is. Never bothered to look it up. I'm sure you can. There's probably a wiki page on it. The basic ROM has all of the information to translate, the basic instructions that you can write. There was a lot of software that came out for this thing as basic programs. You buy a book or a magazine, and you would manually type in a video game in BASIC, and then you'd type play and, play the video game. You hit reset on the computer, or if you goofed and the game froze, you had to start from scratch unless you saved it to a floppy drive or a tape drive. Software was also released on basically audio cassette tapes. And from what I understand, some software was transmitted over radio waves. You could record it onto a tape deck using a boombox or other radio receiver that had a tape deck built in, and then play it back on your Commodore 64 and play pirated software from over the radio waves. Wow! That is some old school high-speed technology. The next chip here, we have the 6510, which is a souped-up version of the 6502, and that is the main 8-bit CPU for this thing. It runs at a grand and whopping 1 megahertz. Now, that thing, the 6510, like I said, it's basically a 6502, but it has some extra control lines and some extra hardware to be able to talk to a lot of the extra peripherals via the PLA. Now the PLA is the next chip. That is this dealy jobber right here. And that is, it's a glue logic. It handles chip select, it talks to the cart port, it handles talking to all the ROMs, it handles talking to the RAM, it does all the magic communication of the bus. Maybe one of these days when I get a whiteboard, I'll throw a block diagram up and I'll kind of explain how that magic actually works. It's pretty interesting stuff, and it's even applicable today with modern computers with how buses work. It's a little simpler and a little kind of more stripped down than something that's new, but it's essentially the same. Any kind of parallel bus works essentially the same way. This chip right here, this is legendary. It is even more legendary than the VIC. This is the Sid Chip. The Sid Chip, oh my goodness. People use these things today. They pull old Sid Chips out of Commodore 64s or pick up new old stock off of eBay or from anywhere else they can get their hands on them. And they build custom MIDI devices, and these chips had a sound that was all their own. It wasn't, you know, high fidelity by today's standard, but it is a very unique sound. And people still use these things to make modern music. Go and Google chip tunes. It is, you will listen to some kind of amazing stuff. It's just magic what people can do with these things. Over here we have these 4 chips, and we have these 4 chips right here. That is actually the system DRAM. This thing had DRAM. And there's an interesting part number here that ends with P-3. That is actually the speed grade of these chips. It's 390 nanosecond, I believe, is the access speed for that part number, or that suffix to the part number. I'll probably try to link in some data sheets down below, so anybody who's has more interest can go and actually look these things up and kind of decide for themselves how awesome 370 or 390 nanoseconds is. Right here. Oh my goodness. I don't think anybody who's ever played with electronics has ever not heard of this chip. Or its brother, little brother. This is a 556. It's a timer. All it does is time things. This one is actually a dual timer. Kind of interesting, used for all sorts of different stuff on this chip, or on this computer. We have a bunch of other interesting chips. Right here we have a Motorola part, or what looks like a Motorola part. I see 3 little diamonds, made in Japan. Pretty good assumption it's a Motorola. Now, that particular chip just happens to be the color RAM chip. Excuse me, I will try to edit that cough out later. I apologize. Anyways, back to this wonderful piece of antique hardware. The rest of these chips over here, they're basically glue logic. They're 74 series and CD glue logic. They're muxes and analog switches and latch chips and oh, what else? I believe there's a hex inverter. Let's kind of look at these part numbers and see what they are. 74 257, 74 257. That is a quad mux. And right here we have a part from Fairchild. It's got an F. I'm not entirely sure. I can't read it that well. We have a 7406 over here. That is a hex inverter. I'm familiar with that chip. That just takes a signal and changes it, inverts the value. Over here we have, oh, I can't read that whole part number. I might just have to link all these parts in later. I'm not wearing my glasses. Oh my goodness, I should know better by now. I'm blind as a bat these days. Anyways, so this is the Commodore 64. It's an amazing piece of technology. I played with one as a kid. There was a game called Mule. They ported that game to everything in my lifetime. It runs on Windows, it runs on Macs, it runs on my Android cell phone. They ported the darn thing to HP calculators and Texas Instrument calculators. Who in their right mind ports video games to calculators? I don't know, but it's been done. Anyways, I love this machine. I wish this one worked. When I ordered it off of eBay, I was planning to plug it in. I got the floppy drive for it. I ordered up some floppy disks that had some video games like Mule. And it came in, and it doesn't work. I checked the power supply. Power supply works okay. I checked the number of voltage rails. Voltage rails are all good. And I still have a black screen. Kind of leads me to believe either one of the ROM chips or one of the RAM chips or maybe even the processor's dead. I have to do a little more digging and troubleshooting to try to figure out what's going on. I know there's a big community online about repairing these things and getting these guys back up to snuff because they are classics, and most of the chips, from what I understand, are either replaceable or upgradable to something a little bit newer that works. The PLA, I think there are 5 or 6 drop-in replacements that are perfectly compatible, that provide all the original functionality and do it better. Yay! We like better. Anyways, that is the Commodore 64. Thank you much for your viewing and attention. I plan on doing a teardown of one of the floppy drives that arrived with this unit. I also plan on, like I said, doing some whiteboard work with it, and hopefully we will get around to really educating the world on the amazing awesomeness of the Commodore 64. Until then, I'm sure a little bit of Googling or DuckDuckGoing, or as I like to call it, DuckDuckFoo, searching can give you a lot more detailed information if you are very intrigued. So have fun Googling and learning.